Okay, my dear students, we are going to discuss the application of chain rule. Okay, we have already discussed the continuity and differentiability of a function at a point. Now our next topic is differentiation of a function. In class 11 we have already discussed about the differentiation of the simple functions like differentiation of x to the power n, differentiation of sin x, cos x, cot x, tan x, ddx of ex, ddx of log x, etc., etc. Okay, those standard results we got in class 11. Now we have to apply the same formulas here also, but the functions may not be given in a simpler way. For that we have to make use of chain rule. Okay, now the topic is like derivatives of composite functions. Okay, here an example is given to us: fx equal to 2x plus 1 whole cube. If you see it, you can notice that this 2x plus 1 whole cube looks like x cube. Okay, if x cube, then it is much easier for us to differentiate, like the differentiation will be 3x square, but it is not x cube. Okay, in order to make it easier, we can take it as another variable. That means this function is consist of two functions. One is like x cube and the other is like 2x plus 1, like this. One is like 2x plus 1 and other is like x cube. Okay, then if we put the function fx in that form of f of zx, then we will get this as 2x plus 1 whole cube. And to differentiate this, we can, the chain rule is here given here. It is what f be a real valued function, and the function is composite of two functions, that is u and v, and if dt by dx and dv by dt both exist, then we can extend this differentiation like this. Okay, and this chain rule can be applied to many composite functions. It may be of composition of 2 or 3 or even 4 functions, then the chain will extend in that way. Here the function is a composition of two functions v and u, so we will have two derivatives here, this and this, this and this. If the function is a composition of 3 functions like w, u and v, then we will have the chain in 3 derivatives, this one, and this one, and even we can extend it to 4 or 5 like that. For that we can have example like this: find the derivatives of the function fx equal to sin x square. Okay, you can notice here it is a composition of two functions. One is sin x and the other is x square. Okay, one is sin x and the other is x square. Then we can differentiate both the functions, the sin x and the x square part. Okay, the differentiation I will show you in my example. Another example here is here: find the derivative of tan 2x plus 3. Look it looks like what? Tan x, and the 2x plus 3 part is different. That means it is a composition of two functions. One is tan x and the other is 2x plus 3. Okay, so in order to make you understand, I have chosen some examples for you so that the application of chain rule is much easier for you. Okay, the first question I have chosen is to differentiate this function y equal to root over 1 plus x square. As it is a function of y and x, here x is the independent variable and y is the dependent variable. That means we have to find the dy by dx. Okay, now let us take this 1 plus x square part as t. Now you can see it is a function of t and x. Here x is independent, t is dependent. That means we are going to find dt by dx from this part. If it is t, then this becomes what? Y equal to root t, and this will give us dy by dt. Now we will write the same, that dy by dx equal to the multiplication of these two, dy by dt into dt by dx. You can see if dt and this dt is cancelled, then dy by dx, which is same as this, we will get. That means these two are equal. Now we will put the requirements here: dy by dt, that means d by dt of y is what? Y is root t, and d by dx is d by dx of t. T means 1 plus x square. Though it is not a formula, but we can have a shortcut for that d by dx of root x is 1 by 2 root x. That means d by dt of root t is 1 by 2 root t. And this part 1 plus x square means 2x. 2 and 2 is cancelled. We will get x by root t. Now one thing we have to remember, that since the question is in terms of y and x, so our answer should also come in terms of y and x. Y and x means here it is already y is there, so this part answer should come in terms of x. We will replace what is t. T is 1 plus x square, so we will put here 1 plus x square. This is the final answer for our example. Next question I have chosen for you, y equal to sine ax plus b whole to the power 5. It is also a composition of two functions. One is sine x, other is ax plus b whole to the power 5, and one is ax plus b. That means composition of three functions, not two functions, three functions. One is sine x, other is ax plus b whole to the power 5, and one is ax plus b. Okay, this is the part that we have to differentiate. Y and x is there, that means we have to find dy by dx. We will take this part as u, the whole part, ax plus b whole to the power 5 is equal to u. Okay, then this y will become sine u. Y and u is there, that means we are going to find dy by du. We will get cos u here, cos u. Then this part let us take as v, ax plus b equal to v. Then we will get dv by dx, which is equal to a. Then this u will become v to the power 5, and we will get du by dv, which is 5v to the power 4. Then dy by dx can be written in terms of a chain in this way. That means the multiplication of these three. Okay, dy by du, du by dv, dv by dx. If you check it, the dv by dv can be cancelled, du can be cancelled. Ultimately it will come to dy by dx, which is same as this. Now we will put for this dy by du is cos u. This is 5b to the power 4. This is a. Now we can arrange it in a systematic way. There is no hard and fast rule that we have to write it in a systematic way, although we will write it in that way so that it looks better. Okay, so 5a v to the power 4 means ax to the power b whole to the power 4, and cos u means this part. This is the answer for our question. Now one thing is that we can do it in a shortcut way also. Instead of writing all those u, v, w, we can have the differentiation directly like this. Dy by dx is equal to ddx of sine ax plus b whole to the power 5. Okay, then this part ax plus b whole to the power 5 we are going to differentiate. Okay, and d by dx of ax plus b we are going to differentiate. That means as there are three functions involved here, one is sine this part, other is this part whole part, and the other is ax plus b whole part. Okay, so these three functions we are going to differentiate. Sine of this is cos of this. This is in the form of x to the power n, so 5 will come here, 5 this whole to the power 4, and the differentiation of this part is a. Now we will write it in the systematic way, 5a, then ax plus b whole to the power 4 cos of this. I think you will find easier this one than the other. Of course you may go for any one, you may like that also, no doubt. Okay, so in this way also we can do. Let us check another example. The question is find dy by dx if y is equal to this part. Dy by dx, here I am not taking u and v. Okay, first we will differentiate the whole part, then we will differentiate the part which is under the square root. As we will remember that d by dx of root x is 1 by 2 root x, 1 by 2 root x, and this is in the form of question. That means we are going to introduce the quotient rule here for the differentiation. We have proceeded in that way, and we will get the result like this. Okay, the same question can be done by using u and v. If we choose this part, the part which is under the square root as u, okay, then this part is u, then this y will become root over u, then we will find dy by du, which is 1 by 2 root u, and this is u in terms of x, so we are going to find du by dx, and by applying quotient rule we'll get this part. Then the chain can be written like this: dy by dx is equal to dy by du into du by dx, and we will put for these two and we'll get the result like this. Okay, next, from exercise 5.2, differentiate the functions with respect to x. Differentiate the function with respect to x. It is sin x square plus 5. You can notice here, and there are two functions involved here. Okay, that means it is a function of composition of two functions. One is sin x, other is x square plus 5. Let us take this x square plus 5 as t or whatever it may be. Okay, it is not that only we have to take t. Okay, we can take u, v, w, anyone we can take, even z also, no doubt. Okay, but here I have done by taking it, but by not taking u and v, I am doing it directly. So dy by dx is equal to d by dx of this part. Then we will write what is differentiation of sine, that is cos of this. As this is not x, this part is not x, so we will differentiate this part again. Then cos of this part is there, differentiation of this is 2x. We will write this 2x here in the front, we will get the answer. You can notice again that sine of this part, that means cos of this part, but this part is not x, so we will differentiate this part again. Okay, with multiplication sign, then we will get the result. Next question, cos of sin x. We are going to differentiate this part, cos of sin x. Here also you can see it is a composition of two functions. One is cos function, other is sin function. Okay, we have to I have chosen y equal to this part. Okay, directly also we can write d by dx of cos of this part, but we can take y is equal to this part, no problem. So we are dy by dx is equal to d by dx of this part. Okay, then as we know, d dx of cos x is minus sin x, so it will come as minus of this part, but it is not x, so that part we have to differentiate again. So minus of this, then d dx of sin x is cos x. This cos x we will write here, minus cos x sin of sin x. This is the answer for this question. Next, sec of tan root x. You can see here there are three functions involved here. One is sec x, other is tan x, other is root x. Okay, so we have to differentiate it for 3 times. Y I have chosen is equal to this, the dy by dx equal to the x of this part. Sec x, you remember it is sec x tan x, so this part, and dy by dx of it is, as it is not x, so we have to differentiate this part again, dy by dx of tan root x. This part will be same. Then d dx of tan x is sec square x, so it will be sec square of root x. As it is not x, so we have to differentiate that part again. Okay, up to this it's okay. Then d dx of root x is 1 by 2 root x. This part we will write here, and rest others will write like that. So this is the answer for our question. Okay, this is just the application of chain rule. Okay, next question you can see, cos x cube sin x square 5. Two functions are there, one is cos, other is sin. Okay, then you can take like this, y equal to this part, then dy by dx of d dx of this part. As it is a product of two functions, that means we will apply product rule. Then u dv dx plus v du dx. In that way, it is sin square x to the power 5. Sin square x to the power 5 can be written like this, sin x to the power 5 whole square. That means it comes as x to the power n formula, x square. So it will be 2x like this, 2f this. As it is not x, so we have to differentiate this part again. Okay, then this part is same, and this part is, you remember cos is there, so it will minus sin x cube will come. As this part is not x, it is x cube, so we have to differentiate this x cube again. Then this is 2 cos x cube sin x to the power 5. and this is sine is there, so cos will come, cos x to the power 5, but it is not x, so we have to differentiate this x to the power 5 again. Then this plus and minus will be minus sine square x to the power 5, here is sine x cube, and the differentiation of this is 3x square. Okay, it is like this, that x to the power 5 differentiation is 5x to the power 4, so ultimately the answer will come like this. And if we multiply 5 and 2, then we'll get 10, and this answer is like this. Okay, okay, next question is 2 root over cot x square. I have taken here y, as I have taken before also. dy by dx we have to find out, then dy by dx of this part. It is like this, dy by dx of c fx, c is constant, so it will come outside. So in that way 2 I have written here, this part we are going to differentiate. Now you can think it as x, okay, root x, then ddx of root x is 1 by 2 root x, so it will be 2 into 1 by 2 of this, but as it is not x, so that part we are going to differentiate again. Okay, 2 and 2 is cancelled, so it is 1 by this, then ddx of cot x, you remember it is minus cosec square x, so it is minus cosec square, x means x square, but as it is not x, so that part we have to differentiate again, ddx of ddx of x square. This part is like this, and it will be 2x. Okay, so this may be the answer. One can go further if somebody wants to make it more simpler, or then they can go further, or if the answer is up to this, then no problem, this may be also the answer. So let us check. It is minus 2, sorry, I forgot to put here x, but x should come here, x. Okay, then this is cot, means cos by sine, as the power is it is root, so power will be half, and then this cosec square x square means 1 by sine square x square. Then these two can be used by using laws of indices, it will be like this. So our answer is this one.